So Curious Jay,
What up?
you seem to have made a friend in the comments on our solar eclipse video here.
Yeah. We posted the curiosity, if you will, over the solar eclipse and the shadow created on Earth. And I was reading through the comments, and there were so many great comments on there. And I came across one of them that actually disagreed with what we were curious about.
Which there's nothing wrong with.
No, not at all.
Absolutely
We
nothing
encourage
wrong.
that. In fact, we ask for that in almost all of these videos. We say, please show us otherwise. But I was reading over a guy's comment, and he actually started saying, look, it's simple triangle. It's a simple mathematical formula. Look at the picture that science gives you. It makes a triangle. There you go. And then, I replied and said, well, with all due respect, the shadow gets larger when you move the object away from the Earth. And please, again, if you're catching this video and you haven't seen the first one, go watch that one. We'll put the link.
Will be in the description.
Yes. So watch the original one first. Read through the comments if you want. But I mean no respect to Mr. Laurent B.
No disrespect.
No disrespect at all.
Lack of respect is disrespect.
I mean no disrespect to Laurent B. for the comment. We encourage those. We encourage those. But he was saying that that's not what we see in reality, and I beg to differ. And then he came back and mentioned how the guys in the video were babbling, and I don't think he realized that who he was. Yeah, right. Like exactly right now. But he said that, look, if they showed an experiment, it'd be better, but they didn't. They didn't even show the experiment they did. So here's what we did. All right. So I went into the basement, Agent S. Okay. And I grabbed one of the studio lights that I have. Don't know the exact wattage, but you can look it up. It's a Westcott Basics, right? It's got 5 switches so it can get really, really bright. I put it 25 feet away from the wall, as far away as possible. You can see that I shut the blinds because it was daytime, right? So I shut the blinds in the room so that there would only be one light source. Turned off all the overhead light in the room. In fact, to prove that there's only one light source, I'm going to go ahead right now and just turn off the lights on this big studio light, okay?
Okay.
And what that basically does is, like I say, I just wanted to show everyone, prove that there's only one light source here, right? So I'm going to flip them off one at a time here. And it's going to get dark here in just a second.
You need one of those stable cams or something.
What's really funny is I noticed while I was doing this, check out the shadow.
Oh,
yeah, check out the shadow. It's larger, right, than the object. Duh. But here's the lights going down, and boom, there's all the lights off. So look, it's a dark room. So bam. Here's the objects I used in the experiment. A coat hanger. We're not professionals, folks, okay? We don't claim to be. Here's some tape and a little bitty plastic cookie.
That's a name brand coat hanger, though, if you think about it.
It's a very classy coat hanger.
Not a dollar store coat hanger.
No. Neither is this tape. This is some good tape right here. So anyway, this is going to be my moon. All right. So I wanted to be able to hold it without my arm casting a large shadow. Put it against the wall and move it away from the wall. And what happens? Well, the shadow gets bigger. It takes a while. You got to go further and further back, but it gets larger. Okay. Now I realized, well, it's tough to show in this video. So I used a box that I could actually write on. Now you can really see it. Watch this. That's the actual size of the cookie there is in pen.
And it's going outside the line. Yeah,
correct.
I can see it. Yeah.
See that? It gets less clear and larger as you go back. Look at that. Look at that. It's larger than the object itself. And this is what we were talking about. And we were told that we didn't do the experiment or show the experiment. So I'm just showing a very basic one right here. Now, I actually went as so far as to mark a second ring. I held the moon or the cookie about 1.5 feet away from the cardboard, right?
Now, to scale, what would you say 1.5 feet would be?
I'm going to get to scale in 1 second. Right
now,
so we're on the same page, because that's what I thought too. Is like, well, it's not to scale. It's not to scale. Okay, first of all, when the sun is supposedly 93 million miles away, it's almost impossible to do it to scale. Okay,
well, we referenced that in the first videos. Some points about being to scale.
Correct.
The way the experiment was. Correct.
Now this is about 1.5 feet away. You can see my second mark on the cardboard, and you see a darker spot in the middle, like they claim. But if we did it to scale, all right, the green circle would represent the Earth at an 8,000, roughly 8,000 miles in diameter. The smaller circle in the middle would represent the size of the moon. Okay. And now let's hit play. Now that's the moon. Now the shadow that shows up on the Earth is actually about 100 miles wide. Okay, that would be this little bitty dot. You see the little dot right there? That would be the little
really.
dot.
I see it. I kind of see it.
It's tough to see, right?
Yeah.
So that would be what science says the shadow is. Now, this drumstick is our moon. It's the same size as the 2,000 diameter moon, right? What I did was I measured, okay, let's get 240,000 miles away. Came out to about a foot away from the source, okay? So I'm measuring here to about right there. So there's my position of the moon. So let's see what happens. We take the drumstick, we move it away from the earth, okay? As we move away, what happens to the shadow?
Gets bigger again.
And we're not even a foot away. Look at the shadow there. It's hard to see, but it's huge. Huge. It's like 5 times bigger than the earth. And that is relatively to scale. Of course, the light source would actually be, probably 50 times further away if we did it accurate, but no way, shape, or form do we ever see this, what science tells us. A little bitty dot, a clear and defined dot shadow about 100 miles wide. It just doesn't happen. Every single time you move an object away, the shadow gets larger. So, to my friend out there who is relying on the geometry to explain away science's diagram, all right, it's simple geometry. He says it's simple triangles, and he trusts triangles. I would say to him and to anyone else out there, please show me an experiment where you can move an object closer to the light and that shadow gets more defined and smaller as it goes.